Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 21 problem of this month on LeetCode. Before starting, if you guys haven't subscribed to my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 762. Prime number of set bits in a binary representation. So let's read the problem statement. You are given two integers left and right. We have to return the count of numbers in the inclusive range left to right, having a prime number of set bits in their binary representation. So recall that the number of set bits an integer has is the number of ones present when written in binary form. So for example, if you write 21 in binary form, so it is going to be like this. So this bit value is 1, this bit value is 2, this bit value is 4, this bit value is 8, this bit value is 16. So 16 plus 4, 20 plus 1, 21. So 21 in binary form is going to look like this. So it has 3 set bits, 3 ones you are seeing here. So 3 is a prime number. So yeah, so we have to then increment the count. So here if you see this example number 1, so left 6, 10. So we have to check for 6, we have to check for 7, we have to check for 8, we have to check for 9, and we have to check for 10. So these are inclusive. So 6, so in 6 we have 2 set bits and 2 is a prime. In 7 we have 3 set bits. In 8 we have just 1 set bit, 1 is not a prime. In 9 2 set bits and 2 is a prime. In 10 we have 2 set bits, so 2 is a prime. So overall 1 2 3 4, so 4 numbers have a prime number of set bits, so 4 is the output. That's it. Here example number 2, so 10 to 15, so 10 11 12 13 14 15. So 10 has 2 set bits, 11 has 3 set bits, 12 has 2 set bits, 13 has 3 set bits, 14 has 3 set bits. So all these are prime numbers, but 15 has 4 set bits and 4 is not a prime. So overall we have 5 numbers have a prime number of set bits, so 5 is the output. And here if you see the constants, so left and right, so value is in this range 1 to 10 power 6, and right minus left, if you calculate the difference, we have to go over all the numbers now from left to right inclusive. So it is just 10 raised to power 4. So we can actually solve this problem in O of n time complexity. It will not give us any issues, right? So here first what you need to do here, like this is your code. So here you have to simply iterate over all the numbers. So let's say for your for loop, for int I is equal to left, start from left, and it should be until right. So I is less than equal to right, and then I plus plus. This is what you need to do. You have to check all the numbers, you have to iterate over all the numbers. Then for every number I in this range left to right, you have to count the number of set bits. So that is very simple. How you can count? There is one function in Java, that is integer. We have integer, I is an integer. In this integer, just calculate the number of set bit count. So you have to just write dot bit count, and in this just pass I. So in this way you are just going to get the number of set bits in one particular number. So then once this is done, then we have to check if this count value is prime or not. This is what we need to check. So here I will just use one method, let's say helper method is prime, and in this is prime, I'm just going to check if in this count we have prime number of set bits. So if it is true, then I will just increment one value, result plus plus. So let's say in result I will store the overall count, so result is equal to 0. Clear this part? And here once all this is done, then we have to just simply return result. That's it. That's it. But here we have to write this is prime. Okay, but here if you see first this thing, integer dot bit count of I, so this is going to run in just of one time complexity. Why I'm saying that? Why I'm saying that? Because an integer has at most 32 bits only. Clear this part? So I can say instead of 32 I can say it's constant only, so it will not run much. And here you are going to check is prime on count. So actually this count can be at most 32 only. since max 32 set bits we have. Clear? Max 32 set bits only we can have. So prime number we have to check until there only. So it is also, you can say, it is also not going to take much time, of 1 only, you can say. This loop is going to take of you are checking all the numbers now from right to left, and plus 1. See here, uh 10, you are checking for these 6 numbers, 1 2 3 4 5 6. So I can say 15 minus 10 plus 1, so that is nothing but 6 only. Clear? Here you see 1 2 3 4 5, so I can say na 10 minus 6 plus 1. So that's why I'm saying here of right minus left plus 1, or in simplicity you can just simply say of n as the time complexity for this one. That's it. That's it. Okay, so now here you have to just simply write the code for is prime. That is also very simple. So here you can, I will show you 2 ways to do this. Private boolean, and here your method is prime, and in this is prime method you are passing one number, let's say n, and in this, if your number n value is equal to 1, so 1 is not a prime, so here you have to simply return false. And here if your n value is equal to 2, then in that case 2 is a prime number, so you have to simply return true. Clear? And then after that you can simply run one loop int, here let's say I is starting from 2 and I is less than equal to math dot square root. This is how we run, right? Only until here we need to run it, and here I plus plus, and here I will check if your n modulus with I and modulus with I, if this comes out to be equal to 0, then in that case you have to return false. And here otherwise if you don't return anything, so you have to just return true, that it's a prime. So that's it. So this is how you write. Okay, so here if I run it, all the test cases has been passed, and if I submit it, so see our solution is accepted, right? So here see, in is prime method, right? This, so this can be at most 32, this is what I'm saying. But here inside this, while checking, so I further reduced it. I don't need to check iterate over this loop for all the 32 or for all the n values. I don't need to do that. Here I am passing the count now. So if all the 32 bits are set, so instead of 32, I'm not going to from 2 to 32. I'm not doing that. So here I'm running my loop only until math dot square root of n. So let's say n is max value 32. So that simply means still it is not going to run for of 32. It is going to run for the square root of this math dot square root of, if let's say max value we have square root of 32, and that is nothing but it's going to be approximate equal to you can say approximate is it's equal to 6, you can say. So that's what, right? So that's why our solution is accepted right here. So no issues, you can write it like this, right? So this is one approach, one way to write this. Or here we know that only until 32 we have to check the prime numbers, only until 32 we have to check the prime numbers. So I can simply do one thing now, instead of doing this, instead of doing all this, I can simply write one line of code here. I have to just check the number of prime numbers until 32 only. So here in the set initially I will add all the prime numbers. So here I will say is prime, and here in this I will, what I will do here, I will just simply write set dot off, and here what are the different prime numbers we have. We have 2 3 5 7 11, then we have 13, then we have 17, then we have 19, then we have 23, and then we have 29, and then we have 31. So only these are the prime numbers we have. And here I will say if my set dot, if my set dot contains what, this count value. So then result plus plus. So let's run it. So now I just reduce the number of lines, nothing else. So see this, all the test cases has been passed. Now let's submit it. So see, the solution is also accepted, right? So here same thing, like in the set only you are checking. So this is also going to run for just of one, and this is for of one, and this is of one. That's it, same time complexity. So I hope that you guys are able to understand both the approaches, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you, bye bye.